The second of the three types of thermal energy transfer that we will discuss in this chapter is heat conduction. Last time we discussed thermal radiation, infrared radiation. Heat conduction occurs in the manner of a row of dominoes tipping over. You tip over the first one and the rest follow. If you place, let's say, an iron bar, one end in the fireplace, the flames will increase the vibrational energy of the molecules at that end of the bar, increase their kinetic energy and momentums, and those molecules in turn collide with their nearest neighbors, which collide with their neighbors, and so on, until the energy reaches the other end of the bar. Same story can be told about the transfer of thermal energy from one side of a wall, shown here, to the other side. So suppose we have a wall of a certain thermal conductivity. Its thickness is X, face area is A, right side, left side, same face area, and the temperature on the left side, T1, temperature on the right side, T2. The difference in temperature is symbolized as delta T. We arbitrarily choose to subtract T1 from T2, but you might want to say that delta T is the reverse. It won't matter because we're going to take the absolute value of the temperature difference in the equation I'm about to show you. The rate at which thermal energy passes through this block, symbolizes R, is measured in watts, joules per second. It's the thermal conductivity K times the face area A times the absolute value of the temperature difference divided by the thickness of the wall. Let's work a simple example involving glass, a window whose thermal conductivity is 0.96. Substituting in for K in this position here, we have 0.96 times those units watts per meter Celsius degree, times the face area of 6 meters squared, times the temperature difference, which is the absolute value of 10 minus 30. Absolute value of a negative 20 gives us a positive 20. And then we divide by the thickness of the wall, making sure to convert from centimeters to meters, 0.02 meters. The surviving unit is the watt, because the meter downstairs with the meter downstairs combine to give a meter squared downstairs, canceling the meter squared upstairs. The Celsius degree symbol cancels the Celsius degree symbol. The watt unit survives. 5,760 watts. If this window were the only outlet for thermal energy from the indoor air to the outdoor air, then a space heater set to 5,760 watts would allow the temperature in the room to be maintained. Thank you for coming. That concludes this introduction to thermal conductivity.